Hello and welcome back to Statistics1. We are going to talk about descriptive statistics for about 2 chapters. And we will start with ways to organize data. Before we organize data, we should know what data is. So the first lecture, 2.1, will be on variables and data. So a variable is anything, is something that changes its value. It's a characteristic that is changing. So you can think of age as a variable, because moving from one person to another, that could be different number, could be the same number, right? We can have 2 20-year-olds. But as an idea, we can use maybe capital A as what we call a variable, and then portray all possible ages within that variable, which would be from 0, right at the birth, to death, which is inevitable, like taxes, pretty much. So now we're going to write a few of these definitions. This section is mostly, again, words and words and more words. And then eventually we'll start introducing some numbers. So, variable. A characteristic that varies from one person or thing to another. So variable is a characteristic that varies from one person or thing to another. I gave you example of age. Could also be shoe size, could be height, could be weight. So there's that part. Things, again, we can think of, let's say, a computer with the variable of how much storage or the speed or whatever characteristic you want to think of. So there are variables, and now those could be qualitative and quantitative, and then discrete and continuous. We'll define all of them. So first, let's go with the qualitative variable. And that would be a non-numerically valued variable. Non-numerically. Immediate example, color. Even though computers do give numerical values for each color, but as we speak, you would not give me a designation of 00256. No. You will just tell me the color you're thinking of. Quantitative variable. Are numerically valued. Variable. I'm just going to give a single example, age. Then we have discrete variable. That's a quantitative variable whose possible values can be listed. In particular, quantitative variable, only a finite number of possible values. It can be counted. That's the gist of the full. It can be counted as separate units. You don't get to go to a store and buy half of an egg. You can maybe pursue a person over there to sell you one egg, maybe. But you can't buy half of one egg. So eggs are sold in discrete, right, numbers. So you can buy maybe one egg, 6, 12, or carton of 30, right? So you can buy eggs, but only whole units. When we talk about people, we talk about babies and rabbits, again, whole units. 1 baby, 2 babies, 3 babies, there is not going to be 3.41. So that's all discrete type of a variable. We'll have the continuous one, that's the next one, where you can have any number. So generally, and then some units that are discrete, we make them, some units that are continuous, we make them discrete. We'll talk about that. So discrete variables, it has a whole paragraph, a quantitative variable whose possible values can be listed. I would just say a quantitative variable that we can count with whole numbers, right? So a quantitative that we can count using whole numbers. I mean, counting numbers, natural numbers, but using whole numbers. And I'll just say eggs. I'll put babies too. And then we have continuous variable. A quantitative variable whose possible values from some interval of numbers. So they give you the interval. Okay. So a quantitative variable whose possible values form some interval of numbers. So it's not really counting. We can have numbers in between the numbers you used. That forms the interval. For instance, if you can think of the car estimate, right? Give you the interval from $100 to $200. Well, in between, you also have 150, there's 130, but then there's also 137, and then there's 137 and 15 cents, right? So it's subdivisible. You can divide into smaller parts and smaller parts and smaller parts. Now, the trick with this is interpretation, because you can say, well, okay, what's smaller than a penny? because we don't really use anything smaller than a penny. So it's a little bit tricky, right? So it could be discrete as well, because I can order and count. I can say $100, $100 and a penny, $100 and 2 pennies, $100 and 3 pennies, $100 and 4 pennies. You see, they're ordered, so it's discrete. But then, given as a interval for the estimate, could be regarded as continuous. Another idea is, you see, when you talk about eggs, it's really clear. You have 1 egg, you have 2 eggs, and there's nothing in between. There's no 1.5 eggs. And if you don't believe me, just go home, take an egg, cut it in half, see what happens. If you have never done that experiment before. I have. Now, and my Calculus 3 students also, they do it too. Now, the question is, how about height? When you are born, you're that big. That's it. Now, you are over 5, right? So, what happened there? Did you grow in increments of an inch a day? So let's say, you grow in your sleep. So, you go to sleep, and there is this instant when you're just like, whoop, inch taller. No, right? It happens over time, gradually. So the height changes gradually. So if the shortest you ever were was on the day when you're born, and up to this moment, it's a gradual change. You took on all of the values in between. You grow continuously, little by little by little by little. There is no, it's not like, okay, 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet, let's say, stop. You don't grow in 6 bursts, because that will be discrete growth, right? You continuously grow. So the number of inches, right, of your length when you were a baby to the number of inches converted now of your height is a continuous change over time. So when you can come up with the interval that is changing continuously like that, the weight goes the same way. You measure it once in a while, but it's continuous change. It takes time to eat, to be heavier. It takes time to go up the stairs or whatever and get lighter. When you're driving your car, the full system, you plus the car, that's the weight of the car. As you drive from your home to school, you are using gas. That gas is converted into other forms of energy. Well, 75% of it's wasted, but it's okay. So, on the other end, the whole system, you plus car, is constantly getting less heavy, because there is less and less fuel in terms of its physical presence in a gas tank as you drive from point to point. So that's a continuous change. So there is a lot of these ideas, and you kind of have to be careful with this particular classification. One of the favorite ones is dates. Continuous or discrete? Yes? Discrete, very good. Yes, the dates are moving on, and then there will be a next year, and there's going to be a January 1 again, and January 2, 2nd, and January 3rd, right? They're all going to be back in this continuous loop, right? But it's discrete because today, Monday, right? Today is Monday, and Monday is going to end abruptly, just like egg ends abruptly. Like there is an edge to an egg, and then that's the end of the egg. So at midnight tonight, there's going to be the end of Monday. And it's the end of today's date. The next day, which starts at that point, is going to have its abrupt start, right? Which is like the edge of an egg or edge of a person. So that's discrete data. There is no let's ease into it, right? You ease into being, I don't know, 300 pounds, right? You ease into it. Just one more Snicker bar, right? There we go. It's a public service announcement. So you ease into either gaining weight or losing weight. That's what it is. It's a continuous change. But the dates, it's abrupt change, right? Immediately. Jump from Monday to Tuesday, jump from the 4th into the 5th. That's it. There is no transition period to linger for, let's say there's this 2-hour period when you really don't know. Well, I mean, some people don't, but it's fine, Especially, whatever. Anyway, so this is what we have. Variable is a characteristic that varies from one person or a thing to another. And then we are classifying quantitative, qualitative, and discrete and continuous. Now, to understand this on this scheme, so you have variables. And they break into quantitative. You can think of these as descriptive, okay? Sorry, I wanted to say qualitative there. Qualitative and quantitative. Quantity, number, right? So quantitative are the ones that further break into discrete and continuous. And this would be our block diagram on how these things break apart. So if I am to say dates, what kind of variable, what type of variable? Dates. You would go and you would say, okay, dates, that's going to be discrete quantitative variable. It's discrete because it ends abruptly. There is no transition. There is no, going into a new day or something. It's just new day, done. Some of the weird ones, we understand that age should be continuous, right? But if I am to ask anyone in this classroom, what's your age? You would not tell me the number of years, months, days, hours, minutes, seconds, milliseconds, microseconds, nanoseconds, picoseconds. You see where I'm going, right? Because you can keep subdividing. Now, we understand it as a discrete. I'm 20 years old. I'm 21. Right? Some people might get fancy. Okay, I'm 21. I'm 20 years old, but I'm only like 20 years, and then I need 11 months. I just need another 7 days, right? Okay, you are getting now into this continuous kind of deal, but it's discrete dates. Shoe size. What do you think? It's discrete. Is your foot growing discrete? No, right? Your foot doesn't grow in discrete, right? It grows continuously, little by little by little, throughout the time. So that's that. Now we have these qualitative data, on the other side, that's no numbers. And that would be color is a good example, probably the best example. When you say, okay, this chair is red, all right, it's data. It's variable because the chair could be blue, could be black, could be green, right? There should be, there are blue chairs in the back. Do we have, oh, there's a green chair right here. You have mostly, oh, you have red chairs as I can see, yeah? Oh. Now someone's gonna come out, that's not red, that's, and then it says the color, and it's red. Yeah. 16 colors is all we need to perfectly understand each other. And that's that. Good. And now, when we assign to these variables values, it becomes data. So, color of a chair is a variable. But when I say red chair, blue chair, black chair, green chair, I am giving you data. Because that is a collection of objects that I grouped together, and I gave values to the variable. So if I observe 30 red chairs and then 10 blue chairs and then 1 green chair, that's now becoming data. So more definitions now. Data. So data is going to be values of a variable. Qualitative data. Values of qualitative variable. Quantitative data. Values of quantitative variable. Discrete data. Values of discrete variable. And finally, continuous data. Values of continuous variable. What are the blood types? A? No.
A, B, F, B, O.
O. O positive. O negative. Good. So what kind of data would that be? Qualitative. Very good. It's non-numerical. Household size. Meaning the number of people living in a house. You have to be more specific. You're correct so far. So it's quantitative, discrete. Exactly. You're not going to find a house with 3.78 people living in it. So it's either 3 or it's 4, or 2 or 1. or 5 or 6. Still 1 unit. It's not out yet, doesn't count. Right? Is it fed separately? No. Good. 1 unit. Wow, we are getting into this philosophy. Well, let's talk now. I mean, when you wake up the demon, right? So what about it? What are your thoughts? Well, I think they should, but please prove me wrong. You don't know. You just wondered. Okay, let's put it out for the floor to discuss 1 or 2 or.
I think it would depend on how closely they're conjoined. Like if they're conjoined from here down, and it's just their heads in the ground eating.
They can't really be in 2 places at the same time.
Yeah, but what if they're conjoined at the hip and then two separate stomachs?
Okay, so, well, thank you for bringing this up. This is a lively discussion, which we can actually definitely drag for at least 2 or 3 classes. Please do the research and bring some interesting things next class. I would love to know this. This never popped up before. Thank you very much. I would love to continue this discussion in the future. Yeah. The more politically incorrect and bad you make it, the more I love it. So bring it on every time. Thank you. This is going to be a great class for that because it's all grim throughout. Earnings from the crypt. Huh? Earnings from the... Michael Jackson made $200 million. Well, that's easy. They recycled him, they make the toys out of him, and there you go. It was mostly plastic. I don't know if you knew that. Yeah, I know. It's amazing. Okay, world's highest temperatures. North America, Death Valley. Great. 134 degrees. It's in a book. I'm reading. Apparently, world's highest temperatures. And there is some World's Meteorological Association revealed the following data. They had it hidden and then just like was revealed. They could just say published, but I guess the word revealed, right, brings more mystery to it. North America, Death Valley, number 1. Africa, number 2 in Kebili. Kebili, there's no N. Kebili, Tunisia, 131 degrees. And then in Israel, Asia, 129. Australia, 123. South America, Argentina, 120. Great. Europe, Greece, 118. Okay, the Philippines are there. So great. Some good. So that's like places you should never visit. That was the list. The next one is 2.7 earthquakes. That's it. That's perfect. Earnings from the crypt, right? That we talked about that. World university rankings. Don't look at the university rank. Look at your department rating, so you can actually learn something. Caltech, overall score of 95.5, followed by Stanford and Oxford and Harvard, MIT, Princeton. Rutgers is missing on this list. Oh, it goes only to 10. I see. All right. Like recording industry statistics. Good. So they have some cool stuff for you to look into here. It's not all doom and gloom. Top 10 green cars. They're painted green, I guess. It says Nissan Leaf electric, Tesla Model S electric, Ford Focus electric, Chevy Volt hybrid, Toyota Prius hybrid, Ford C-Max hybrid, Volkswagen Jetta hybrid, Honda Fit electric. Electric car is not green. It uses electricity. And where the electricity comes from?
Depends.
It comes from?
It depends. Depends where you are. Some places will be 100% renewable. Some places will be 100% coal. Depends.
Yeah, well, mostly in the United States is.
Coal.
And? Nuclear fission.
If you're charging your car at home, you probably have solar panels on your roof.
Yeah, it's still negligible. In comparison to how much electricity comes from, from the dirtiest sources. The only reason to have electric car is efficiency. I mentioned earlier that 75% of your gas money is thrown in the garbage immediately. So if you pay for a full tank of gas $40, since your car is about 27% efficient, the older the car is, the worse it is, 25% of your money that you put into gas goes towards driving you from place A to B and your air conditioning and your music and stuff. That's 25%. And 75% is in friction and heat and explosions and all of the other things that are happening in the car. It's called wasted energy. Electric car, Tesla, is 98% efficient, which means that 98% of money that you put into electricity that goes into its battery is used for the stuff, and 2% is wasted. So that's the reason why electric cars are insanely better deal than the gas car. It's not just, there's no maintenance, no oil change, no engine, less service and less everything. Sure, that stands there. It's not green because it's still using, it's generating nuclear waste, which we bury in a mountain, in US at least. So you want the electric car because of efficiency, meaning that all of the money that you put into the car goes to you to drive from place to place. And then eventually, obviously, autonomous driving. That's going to put in place when it's ready. We won't have a choice. It's just going to flip the switch on that one. So that's a good future to look into. But now we have what we have, and that's it.